Hello everyone. Your today experiment is about chemical kinetics. We're gonna consider kinetic and the rate of a reaction. The reaction which we're gonna consider is conformation of tertiary butyl alcohol from tertiary butyl chloride in reaction with water. So here water is a reactant. In addition to that, the water is solvent. So these kind of reactions are called solvolysis. Uh, Solvolysis is a type of reaction where solvent acts as reactant, like here. Water is solvent and reactant. Hydrolysis, we have two different kind of other kind of reactions: hydrolysis and alcoholysis. So hydrolysis is a type of reaction where water acts as a reactant, just reactant. Alcoholysis is a type of reaction where alcohol acts as a reactant. But the reaction which we're going to today consider its rate and the kinetic of the reaction is a solvolysis reaction where water acts as a solvent and reactant. So, about the mechanism of the reaction, the first step is formation of tertiary butyl carbocation, which is a slow step, and then the fast step is attaching of the water to the positive center of the carbocation, and then this step is a fast step, and then the next step is reaction between chloride ion and the hydrogen. So we will have hydrogen chloride and the tertiary butyl alcohol. The solvolysis reaction is a nucleophilic substitution reaction. So you can see here the the chloride ion was substituted with OH group. So it's a nucleophilic substitution reaction. In this particular reaction, the first step, the elimination of the chloride, is a slow step. And usually the slowest step is the rate determining step. Overall rate of the reaction is often depends on the rate determining step, which is the slowest step of the reaction. So here, formation of tertiary butyl carbocation is the rate determining step of this reaction. As the rate determining step contains only one reactant, tertiary butyl chloride, the reaction is unimolecular. So this nucleophilic substitution reaction is SN1 type of reaction. One stands for unimolecular because you can see contain just only one reactant. The other reactant is the solvent. We have not a separate reactant in addition to tertiary butyl chloride. That's why it's SN1 and the reaction is unimolecular. So about the rate of the reaction, rate of SN1 reaction depends on concentration of tertiary butyl chloride. So that's why the rate of the reaction equals K1 multiple the concentration of tertiary butyl chloride. K1 is the rate constant. SN1 reaction is a first order reaction. So again, I'm going to emphasize that the first step of the reaction, tertiary butyl carbocation step, formation of tertiary butyl carbocation is the step which will determine the rate of the overall reaction. So if we are going to achieve the rate equation, so we need to follow some steps. At first, let's say concentration of tertiary butyl chloride at any time t will be Ct, and the rate of reaction for SN1 reaction will be K1 multiple Ct. K1 is the rate constant. Rate of loss of tertiary butyl chloride concentration is K1 Ct at any time t. at time t. So minus dct over dt will be kct. It's your equation 1. So for the next step, let's say at very beginning, I mean t equals 0, the concentration of tertiary chloride was C0. T is 0. So our Ct will be C0. So integration of equation 1 will be minus ln Ct to C0 equals K1T. So, and you know ln x equals 2.303 log x. So we can substitute it in the equation and we will have minus 2.303 log Ct over C0 equals K1T. So that's your equation 2. So, but based on the reaction which we are going to consider today, one molecule of tertiary butyl chloride produces one molecule of hydrogen chloride. So we can consider the rate of the reaction based on the concentration of hydrogen chloride, because during the reaction we can't consider concentration of hydrogen chloride by using titration. So if we call HCl infinity, it means the concentration of HCl at the end of the reaction will be the initial concentration of tertiary butyl chloride, C0. C0 equals to HCl infinity, the concentration of HCl at the end of the reaction. So at any time t, HCl will be C0 minus Ct. So it means, so the concentration of HCl which we have is the initial concentration of tertiary butyl chloride minus the concentration of the tertiary butyl chloride which was used to have the hydrogen chloride and tertiary butyl alcohol. So we can have here, we can change the equation like this: Ct equals C0 minus HCl, or Ct equals HCl infinity minus HCl, because HCl infinity equals to a initial concentration of tertiary butyl chloride. So equation 2 will be like this: 2.303 log HCl infinity minus HCl over HCl infinity equals minus K1T. It's equation 3. So here we're gonna do titration of hydrogen chloride, which is producing during the reaction by using sodium hydroxide. So we can change the equation 3 to this, into this way. So we can substitute HCl concentration to the milliliter of sodium hydroxide, which is will be used for titration of hydrogen chloride. So the final equation will be like this: log milliliter of sodium hydroxide, which will be used for infinity solution, minus milliliter of sodium hydroxide, which will be used for titration of HCl at time t, over milliliter of sodium hydroxide, which used for titration of HCl in infinity solution, equals minus K1 over 2.303 multiple T. So the final, to consider the rate of this reaction, the final target is achieving amount of K1. K1 is a sign for the rate of the reaction. So what procedure which we're gonna follow? At first, we need to fill the 50 ml burette with 0.04 normal sodium hydroxide solution, and then you need to prepare your stock solution using plastic pipette. Measure 1.2 milliliter tertiary butyl chloride in a 100 milliliter volumetric flask. Fill your 100 milliliter volumetric flask with a solution of mixture of water and 2-propanol. The ratio of this mixture is 1:1. So mix well the mixture. This is the stock solution. So the next step is preparing your infinity solution. 10 milliliter of your stock solution must transfer to 125 milliliter Erlenmeyer flask and add 10 milliliter water. Mix it well, keep it aside. It's your infinity solution. So now you need to titrate your stock solution at 5 different times: 10 minutes, 20 minutes, 35 minutes, 50 minutes, and 75 minutes. So at each of these times, you need to take 10 milliliter of stock solution and add it to a 125 milliliter Erlenmeyer flask and add 10 milliliter acetone, and then adding 1 to 2 drops of bromothymol blue as your indicator. And so after adding your indicator, the color of the solution will be yellowish. And then titrating the mixture by using 0.0 for normal sodium hydroxide solution, which is in your burette. So the end point will be where your solution's color changed to pale green. So at this point, you need to record the volume of sodium hydroxide which you use for titration. For each of these times, you need to repeat these steps. So then you need to titrate your infinity solution. Add 1 to 2 drops of your indicator, so the color of the solution will be yellow. Titrate the solution, the mixture, by using sodium hydroxide to have the pale green color in your solution. I record the volume of the sodium hydroxide which you use for your infinity solution. So then you need to calculate. You need to have some calculation. So for your different times and your infinity solution, you will have milliliter of sodium hydroxide which you use. So based on it, you can calculate. Let me show you. You can calculate the left side of the equation 5, because in the left side you need the milliliter of sodium hydroxide for infinity solution and milliliter of sodium hydroxide for each of those times which you did the titration: 10, 20, 30, 50, 75. And so milliliter of sodium hydroxide again for infinity solution. So calculating of these left side of the equation is extremely easy. So after calculation, you will have 5 points. You will have the amount of these equation for 5 different times which you did the titration: 10, 20, 30, 50, and 75. So you can draw the curve for which will be a linear graph with this amount of the left side of the equation versus time. So when you do this, you will have kind of a linear graph, and you can have the equation of the linear graph. So in the equation, the slope of the equation is the number which you need to use it for calculating K1. Why? Because based on this equation, which is kind of linear, the slope and the coefficient of t is the amount which contain K1. So a slope here, for example, is minus 0.0062. So minus 0.0062 equals to minus K1 over 2.303. So you can calculate the K1 easily. It will be 2.303 multiple 0.0062. And so you will have your K1, the rate constant, at the end of the calculation. So in addition to equation, you will have R square. R square is a sign which you can conclude that how the linear fit. So when the R square is close to 1, the linear fit is good. But when R square is close to 0, the linear fit is bad. Usually R square is between 0 to 1. And when it's closer to 1, it is better. Okay, guys, that was your today class. Good luck.